Let's solve this rational equation. When I solve a rational equation, I can take one step and I can make all of these denominators disappear. What you need to do is you need to find the LCD and multiply everything through by the LCD. Now I know my LCD is going to have an x plus 3, and I also know it's going to have an x minus 1. But I need to factor this to see what the factors of that term are. So let's go ahead and do that. I'm going to have 2 over x plus 3 plus 3 over x minus 1 equals negative 13 over, let's see, this is a trinomial. It starts with a 1, so it's an easy one. I can go to my two binomials. They are going to start with x and x, x and x. Two numbers that multiply to give me 3. Well, that's only 3 and 1. And they're going to subtract to give me 2. Yep, 3 minus 1 is 2. So I will have a 3 and a 1. Larger one needs to be positive. Okay, so when I go to find my LCD, I need an x plus 3, and I need an x minus 1. And would that be able to cancel this out? Yes. Would that be able to cancel this out? Yes. Would that be able to cancel this out? Yes. So let's multiply everything times that LCD. Every term times x plus 3, x minus 1, times x plus 3, x minus 1, and x plus 3, x minus 1. Okay, we're really multiplying both sides. All right, now this, let's see, this cancels with this. So I will have x minus 1 times 2, and I'm going to write it as 2 times x minus 1, plus these cancel. So I will have 3 times x plus 3 equals, and then both of these in the denominator cancel. Leave me with negative 13. Okay, now, what happened to your denominators? Right? Magic, right? They canceled out. Now it looks like a linear equation, so let me distribute. I'll have 2x minus 2 plus 3x plus 3 times 3 is 9 equals negative 13. Distribute, combine like terms. These two will go together. 2x plus 3x is 5x. These will go together, negative 2 plus 9. I don't have to move them to different sides. They're on the same side. Negative 13. All right, now let's isolate this grumpy old x. Wants to be all by herself. We are going to subtract 7 on both sides. So 7 minus 7 is 0. That's gone. So I have 5x on the left equals negative 20 on the right. That looks good. I don't think I'm going to get a fraction. That makes me happy. I like when I get an answer that's an integer. Divide both sides by 5, so these reduce. And x equals negative 20 over 5 is negative 4. Now, every time you get an answer for a rational expression, you have to make sure that it's not one of your restrictions. My restrictions here would give me a 0 in the denominator. So, let's see, if I plugged in a negative 4 here. Negative 4 plus 3 is negative 1. That's okay. It's not a 0. If I plugged in a negative 4 here, that would give me a negative 5. That's not a 0. And then if I plugged it in to these two, I wouldn't get a 0 either. Okay, so this one checks out. That's your answer, negative 4.